Hey guys, it's Professor Sensky at UNC Charlotte, and do a little Grasshopper tutorial here for week 2. This is part 1. Just going to be talking about basic transforms, which is going to be a review of the stuff we covered last time. Okay, and to refresh your memory, a transform is like a 3D term, which means to move something, or rotate something, or scale something. Okay, and we looked at a couple of those ideas last time. So just real quick, I'm going to go ahead and start off with something like a polygon, so we can actually see what it is we're doing. Start with a primitive, put a polygon onto the stage here, and just going to do, this is, let's see, 6-sided. I'm going to go ahead and set that to 3-sided, and that's going to let me see some direction here. Okay, so I got basically triangle, okay, and that triangle has a base plane and some kind of radius, and again the number of sides, 3. Okay, and the triangle, the polygon gives us the polygon curve itself, and that's what we're going to be manipulating. So, real quick, the first one we did was move, and if you remember, move takes some geometry. It doesn't even have to be a curve. It can be a surface. It can be like a solid, which is a collection of surfaces. It takes any kind of geometry, but in this case, it's taking a curve, and it wants a vector. Okay, and remember there are different kinds of vectors, right? It takes any vector, but the ones we looked at would be, the z vector. So we have a z vector, which is one we're looking at in our lab session, and a z vector, right, is moving something in the z-axis, and we can tell what axis is which by looking at the compass, that's in the bottom of the screen here, right? That's going to tell us that z is up and down, okay? And z takes a number, and we can control that number. An easy way to control that number is through a number slider, right? Again, there are other ways that we'll talk about later, but the easiest way is just to input a simple number. So I'm going to finish the slider off here. So you can see that increases the magnitude of the z vector, which then moves the geometry. And again, we have the original state of Grasshopper, which is the polygon, and then the new state of that polygon that's been moved. So there are 2 states of that polygon in the Grasshopper sketch, and we can do different things with those. Okay, so it's kind of like a copy, but not exactly. Okay, and we can do different vectors. So that's a z vector. If you wanted to move something, this way back and forth, you could take a y vector, like a unit y, right? And if I plug that in, now notice that moves it to the left and to the right. Okay. If we had a cross section that was actually drawn in the zx plane, that would be a way to actually distribute something across that. If we made our slider negative, say if we had minimum negative 15, we could not only move something this way, but also back this way. Okay. So again, move is one of those transforms. It's the most basic transform, and it allows us to make another state of the geometry by displacing it with a vector. Okay. Now, another kind of thing. Actually, I'm going to go ahead and delete this and do a z vector again. There we go. Okay, so I can look at this. So I've moved it, and then another transform we looked at was scale. Okay, and scale, just like the other transform move, takes geometry. Something interesting's happened here. Okay, you can see that this is the one we moved, the green one, and this green one is the state in which we scaled. But something's happening here. There's kind of a bug. Like it seems to have scaled it in the center here, and I wanted it to scale, inside of here, right? I wanted to make a scale state of this. And what happened? Well, if you look at the center of scaling, it's actually set to 0, 0, 0, which is about right. So between here and 0, 0, 0, right, is this space, and that's actually what it's been scaled to. So how would we get that to scale in the right location? Well, one thing that you could use is a component called area. And I talked about this in the supplemental video that I posted on Saturday. And an area component takes geometry, and it can do curves, it can do meshes, it can do surfaces, things like that. And it returns the area in as a square footage or square inches, but it also returns the centroid, which is the mathematical center of that geometry. Okay, and that works for any shape, not necessarily just a polygon. It can do anything. Okay, and so what we can do is we can plug this geometry into this, and you see that point appears, and that's the centroid. Okay, and if we take the centroid and plug it into the center scale, that's going to give us the proper location for that new scale state. Okay. Now, what we didn't talk about is the scaling factor, which is a number, and you can control that with a number slider. Okay, so we can make a number slider. I'm just going to call this scale. Let's call this height. I don't do a very good job of naming these, but I really should for you guys. Okay, so scale. Now, you'll notice something about scale that needs to be explained. The scaling factor is a percentage, right? It's essentially a multiplier of that dimension. So if our geometry, let's say, is 1 unit, if I take it by a scaling factor of 0.25, that's going to scale it to a quarter size, and that seems to be what's happened here. If I made it a scaling factor of 1, it's 1 times the thing, and that's 100% scale, it's the same size. Okay. On the assignments, I noticed a lot of people were putting parameters into it that made it seem like you were looking at it like a radius or like a diameter. Okay, and it's not an actual dimension; it's a scaling factor. Okay. If I wanted to scale this by twice the size, I might go in and change this to 2, and now it's twice the size, or it's 1.5 times. Okay, so you just have to remember that about scaling factor is that it's a percentile. Okay, if you wanted to make it scale a certain size based on the size of this, and it was always going to be dependent upon this geometry size, instead of putting a slider in for the factor, you could just set it to be a certain size. And in this case, this is going off my screen here. In this case, it's half. I could make that something like 0.667. Okay. And so that if I change the size of this geometry, whatever comes after it is going to be 0.667 of that. So it's dependent upon that geometry. Okay. So again, the two gotchas with scale is that it has to be, you need a centroid, you need the proper center point in order for it to be scaled. Otherwise, you can get some strange bugs. And 2, the scaling factor is a percentage. Okay, so those are two important things. Okay, and then the last transform that I want to talk about is rotation. I'm going to go ahead and delete this scale piece for now. Okay, so I want to do rotate. Okay. Some people were doing this for the assignment. We didn't describe rotate, so I do want to take a second to talk about rotate. And rotation, we shouldn't be surprised. It takes geometry. It takes a G, right? And so we can plug some geometry into it. And it also takes rotation angle in radians, and that's key. So this is another reason why I want to read these labels, because it actually takes the angle in radians. We'll talk about that in a second. And then last, it takes a rotation plane. Okay, so it's looking for it needs an axis to actually rotate it around. So we'll look at that. Let's address the angle first. And the angle ideally would be, right, in this case, maybe a number slider. And there's 360 degrees in an angle. Okay, so we'll just make this 0 to 360, and I'll plug this into angle. And as I scrub from 0, you can notice that it's spinning way more than it should be. You should only get a full rotation in 360 degrees. What's the problem with that? Well, the problem is that it wants the angle in radians. So what do we do about that? We can go into angle, and this is very similar to processing. We actually had to do this in processing, if you remember, because it also wanted rotation in radians. So if I go in, I can go to expression, and I can click the expression editor, and if you click here, you can see all the functions that Grasshopper takes. And I don't expect you guys to know all these, but these are roughly some of the things we were doing with processing. And there is actually a function, radians, that converts an angle in degrees to radians. So if we give it degrees, it returns radians, and it's a function, rad, capital R-A-D, of x. And this is one of the reasons why I wanted you guys to do processing first, because now you understand what a function is, and you can plug this in. So we'll take it rad, parentheses, x, parentheses, okay? And a is the number here, this is the variable, so let's just do rad, a, parentheses. And it says no syntax errors detected, so that's good news for us. Okay, and if I go back to my sketch, you'll notice that if I have it here, I get a full rotation 360. Doesn't quite look like it because it's the same on all sides, but take my word for it, it's a full 360. It's a single rotation. And that's about what we want. We want to be able to control that. If you rotate any more than 360, it just goes around again, so that doesn't really matter. Okay. One last thing that may come into, that may be important is the rotation plane. If you have some geometry that is not rotating the way you expect it to, it might be because the rotation plane isn't accurate. And one way to do that with this kind of geometry might be to take the center of the geometry and then plug the center in for the plane. And that certainly doesn't hurt in this case. It doesn't seem to be necessary, but that might be a bug you run into. If it's not rotating the way you want to, then you might have a problem with the plane. And we'll talk more about planes in Tuesday's lecture. So these are the three basic transforms, and you can do a lot of things with your geometry with these, and those are the ways they work. So you just have to understand what move wants and what scale wants and what rotate wants. Okay, and that should ease you through some of the bugs. Okay, that's the end of this part. I will see you in part 2.